The aldehydes and ketones undergo nucleophilic addition reactions. The carbonyl group is highly reactive polar group. It is polarized due to the higher electronegativity of oxygen in comparison to carbon. As a result, the electrons between carbon and oxygen are more towards oxygen atom. Consequently, the carbonyl carbon is positively charged while the oxygen is negatively charged. Therefore, a nucleophile attacks the electrophilic carbon atom, which is positively charged, of the polar carbonyl group from a direction approximately perpendicular to the plane of the sp2 hybridized orbitals of the carbonyl group. During this process, the pi electron pairs between carbon and oxygen gets transferred to the oxygen atom. This gives rise to an intermediate having a negatively charged oxygen atom. The net result is the addition of nucleophile and H plus across the carbon-oxygen double bond. Both the aldehydes and ketones react with hydrogen cyanide to form addition products known as cyanohydrins. It may be noted that the reaction occurs very slowly with pure HCN. Therefore, the reaction is carried out in the presence of a base which acts as a catalyst. The base removes a proton from hydrogen cyanide and readily produces Cn- ions and makes the reaction fast. In actual practice, HCN needed for the purpose is produced in reaction medium by the action of dilute mineral acid on sodium cyanide. The reaction is believed to proceed as follows. The positively polarized carbon and carbonyl group is attacked by strongly nucleophilic Cn- with the simultaneous transfer of pi electrons to oxygen. The oxygen then combines with H plus to give the cyanohydrin. Aldehydes react with alcohols in the presence of dry HCl gas to give geminal dialkoxy compounds. These compounds are called acetyls. In the first step, the addition of one molecule of alcohol to an aldehyde gives a hemiacetal. The hemiacetal contains both an ether and alcohol functional group. It is an unstable compound and reacts further with another molecule of alcohol to form stable acetyls. Dry hydrogen chloride protonates the oxygen of the carbonyl compounds and therefore increases the electrophilicity of the carbon, facilitating the nucleophilic attack of the alcohol molecule. Dry HCl gas also absorbs the water produced in these reactions and therefore drives the equilibrium in the forward direction. The reactions are reversible and therefore the acetyls formed can be decomposed by dilute mineral acids to give back the original aldehydes. Aldehydes and ketones react with a number of ammonia derivatives in weakly acidic medium to form compounds containing carbon-nitrogen double bonds with the elimination of water molecule. The reaction is reversible and is catalyzed by acid. The equilibrium favors the product formation due to the rapid dehydration of the intermediate to form C double bond N and Z. Some of these compounds are crystalline and are used for the characterization of aldehydes and ketones. Reactions with hydroxylamine to form oximes. Aldehydes plus hydroxylamine gives aldoxime or ethanol oxime plus H2O. Acetone reacts with hydroxylamine to form acetoxime or propanone oxime plus H2O. Reaction with hydrazine with acetaldehyde form hydrazone and acetaldehyde hydrazone, which is also named as propanone hydrazone, plus water. Acetaldehyde reacts with phenyl hydrazine to form ethanol phenyl hydrazone plus water. Acetaldehydes reacts with 2,4-dinitrophenylhydrazine to give 2,4-dinitrophenylhydrazone, and that 2,4-dinitrophenylhydrazine is also called DNP or British reagent, and it is used for the confirmatory test of carbonyl group. It reacts both with acetaldehyde or aldehyde or ketone. Aldehyde or ketone reacts with semicarbazide to give semicarbazone. Acetaldehyde or acetone, or that is ketone, reacts with ammonia. Aldehydes reacts with ammonia to form aldehyde ammonia adduct, and which is called aldimine or imine compound. Aldehydes and ketones react with Grignard reagents to form addition products. When the addition product is hydrolyzed by water, it gives alcohol. Now, Grignard reagent is alkyl magnesium halide. Alkyl may be methyl or ethyl or propyl, and halide may be chloride, bromide, or iodide. And Grignard reagent is prepared by the reaction of alkyl halide with magnesium in presence of dry ether to form RMgBr or RMgX, where R is carrying a negative charge and Mg is carrying a positive charge. Since R is carrying a negative charge, it is a nucleophile, so it must react with the nucleophilic center. It must react with the aldehyde or ketone where a nucleophilic center or nucleophilic carbonyl carbon is present. So when a Grignard reagent reacts with formaldehyde, it produces an 1 degree alcohol. When it reacts with acetaldehyde, it forms a 2 degree alcohol. When it reacts with acetone, it gives 3 degree alcohol. We will see more in our next upcoming video, so please stay with us.